Math 76, Lesson 16, rounding whole numbers, estimating, and bar graphs. So rounding whole numbers is, whoops, whoa, my camera scraped against my microphone. All right, hopefully that didn't sound too terrible for you guys. So for estimating whole numbers, we have to remember our rule in rounding, which is that if we make a number line from 0 to 10, and we put the number 5 in the middle, the number 5 is slightly closer to 10 than it is to 0, and anything less than 5, so like the number 4, gets rounded down to 0. So remember the rule: 5 and above goes up, 4 and below rounds down. So let's go ahead and take this and apply it to a problem. Like, let's say we wanted to round. Oh, and then this can also be done to place value. So let's say we've got the number 86, and I want to round this to the nearest 10. So what I'm going to do is I go to the tens place, which is right here on the 8. I look at the number immediately to the right, and that is where I'm going to apply this rule of 5 and above up, 4 and below down. So since 6 is 5 or above, this number is going to round up. So this 9 will round up to 90, or not 9, this 8 will round up to 90. So if I want to round 86 to the nearest 10, it will be 90. Now let's try something else. Let's do hundreds place, right? So let's take the number 454. Yeah, this will be interesting. 454. No, I did that backwards. It's supposed to be 45. Sorry. Let's take 445, and let's round this number to the nearest 100. Now, some of you will be tempted, since we're rounding to the nearest 100, to round this 45 up to 50, and that is wrong. Remember, when we're looking to round, we look at the place value we want to round to, in this case the hundreds place, and I'm only going to look at the number immediately to the right. I do not care about any numbers after that. So I look at the 4, I look at the number immediately to the right, that falls in 4 and below, so this 4 is just going to round down to 400. So to the nearest 100, that would be 400. And again, like if we're rounding to the nearest 1,000, so let's say we have 6,789, and we want to round this to the nearest 1,000. We go to the 6, we look at the number immediately to the right, we ignore the rest. The 7 is going to round this up to 7,000. Okay, so that's rounding. Now let's talk about estimating. Estimating is a quick way to get a close answer. Now estimating does not get us a correct answer, but it gets us a close answer, which is usually very, very useful. So your book will tell you to do something like estimate the sum of 467 and 312. So the way we would estimate the sum is we're going to round each of our numbers to their first place value, all right? So, or their highest place value. So since this number is in the hundreds, I'm going to round it to the nearest 100. This number is also in the hundreds, so I'll round it to the nearest 100 as well. So let's go ahead and round 467 to the nearest 100. So I go to the 4, I look at the number immediately on the right, that's going to round up to 500. Now I go to the 312, I look at the 3, look to the right, the 1 makes this round down to 300. Now I need to estimate the sum of these numbers, so I'm going to add my rounded numbers. 500 plus 300 is 800, and that is an estimation, which is my correct answer. So that is how you estimate. You round each of the values, and then you add those rounded numbers, and you get your estimate. So estimates are very, very quick. They can get you a useful number, but they're not always they're not 100% accurate. Now, the last thing we're going to do is learn how to read a bar graph. So here in your book, we have a bar graph, and this bar graph tells us about the people living in Ashton County. Now you'll notice a bar graph has data on, or numbers on the left, numbers on the right, and then it also has label on the left and label above on the right. So the label right here is the title, which is the population of Ashton from 1960 to 1990. These numbers on the right are different years. So this would be the population in 1960, in 1970, 1980, 1990. And this number on the left is the population in the thousands. Sorry, I gotta collect my thoughts. I just got a visitor really quick. So I gotta remember where I was in the video. That's right, we were talking about the bar graph, the people in Ashton, what all these numbers mean, and the last thing we said was population in the thousands. So, what this means by population in the thousands is that this 2 is not actually the number 2. This 2 has a place value of 1,000. So this is actually 2,000. This is actually 4,000. This is actually 6,000. This is 8,000, 10,000, etc. So then what that tells us is the space is in between 0 and 2. If this number is halfway in between 0 and 2, then it's approximately 1,000. Or like this one right here in 1960, the bar stops right in between 2 and 4. So I'm going to say that that is 3,000. All right. Here on 1970, it stops directly on 4, so that's 4,000. In 1980, we're in between 4 and 6, so this would be 5,000. And in 1990, we're in between 6 and 8, so this is going to be 7,000. Right? So that's how you read a bar graph. The information all around it is very important, and you can use this bar graph to answer questions. They can even do larger, smaller difference questions. Like, for example, they could say, how much larger was the population in 1980 than in 1960? So what we'd do is we'd look at 1980, we'd see the population here is 5,000. In 1960, it was 3,000. We'd say 5,000 minus 3,000 is equal to 2,000, and then we have our answer. So that's how you read a bar graph. That's it for lesson 16. If you have any questions, let me know on the school website, and I will see you in class.